Hi, I'm Mathematics, and this is the 2020 AIME 1 problem number 7. Before the video begins, make sure you have a solid understanding of combinatorics and complementary counting. But if you don't, that's okay. Keep watching the video and let me know down in the comments below what you want to see next. Alright, so let's start off with a warm-up problem. Find the number of 3-digit numbers with at least 2 repeating digits. Oops, that's supposed to be digits. Let's just fix that there. All right, so let's check our cases. So we have case 1, which is no repeating digits. No repeating digits. All right, digits. So let's check case 2. Case 2 is there are 2 repeating digits. And case 3 is that there are 3 repeating digits or all repeating digits. There are 3 repeating digits. All right, so what we want to find is we want to find the number of 3-digit numbers that lie in these two cases. But what we observe is that that's just the same as the number of 3-digit numbers minus the number of 3-digit numbers, that lie in this one. So let's calculate that. Let's calculate what is the number of 3-digit numbers. Well, that's going to be 999 minus 100 plus 1, which is 900. The number of numbers that have 3 digits with no repeating digits, well, that's going to be 9 times. So we would ordinarily have 10 for the next one, but we've already used 1, so it will be 9. And then times 8, which is 9 times 9 is 81, times 8 is 648. All right, so now we take 900 and subtract from it 648. And if we do it correctly, we should get 252. So 252. There. So our answer is going to be 252. Now make sure you see why this works. We're taking the total number of cases and we're subtracting the number of unwanted cases. Now this is called complementary counting, and it's going to be really useful in the next problem, which happens to be the 2020 AIME 1 problem number 7. Alright, so the problem reads, a club consisting of 11 men and 12 women need to choose a committee from among its members so that the number of women on the committee is one more than the number of men on the committee. The committee could have as few as 1 member or as many as 23 members. Let n be the number of such committees that can be formed. Find n. All right, let's do a bit of casework here. So first, we're gonna set up a table. Let's set up a table of the number of men, so number of men and number of women. All right, so if there is 0 men, then there's 1 woman. 1 man, 2 women, 2 men, 3 women, and so on and so forth, to 11 men and 23 women. All right, so let's look at this. Remember how I said this is similar to complementary counting? Well, how would we be able to count the complement of something? Well, the idea, it's not exactly complementary counting, but it's counting something that's identical. This is called one-to-one counting, and it's a very similar concept to complementary counting. In one-to-one counting, you actually count the number of in one-to-one counting, you count the number of cases in an identical problem. So let's check what would happen if we looked at the number of non-selected men, the number of NM. And what I mean by this is the number of men that weren't selected for the committee. So if 0 men were selected, then 11 men would not be selected. If 1, then 10. If 2, then 9. so on and so forth down to 0. Oops, 1 second. This should be 12. Sorry. So now we see an interesting pattern. 1 plus 11 equals 12. 2 plus 10 equals 12. 3 plus 9 equals 12. So we wonder, is the number of non-selected men plus the number of women always equal to 12? So let's try and generalize this. Let the number of women equal n. Let the number of women selected equal n. Then the number of men selected, then the number of men selected equals n minus 1. Now, let's check the number of non-selected men. So the number of non-selected men, then number of non-selected men is going to be equal to 11 minus n minus 1, which is equal to 12 minus n. So, number of women plus number of non-selected men is always equal to 12. So, we know that the number of women plus the number of non-selected men is always equal to 12. So, here comes the major part. We see that if we chose any number of people, if we chose any number of 12 people rather, then some number k of them would be men. So if we chose 12 people, so chose 12 people, then k are women, and we let the 12 minus k people, the other 12 minus k people, be men. So let these people be men, but let these people actually be non-selected men. Non-selected men. Then the number of people who are selected men is going to be 11 minus 12 minus k, which equals k minus 1 selected men. So you see here that if we choose 12 people out of these 23 people, then that forms a single case. So the answer is 23 choose 12. And we are done. Thank you all so much for watching. Please don't forget to like and subscribe, and I'll catch you all in the next video.